Good morning everyone. Last time I have discussed with you acceleration and its numericals and one more topic which is graphical representation of motion. Yesterday I couldn't complete that topic, so I will continue graphical representation of motion again. So first is draw distance time graph for uniform speed or uniform motion. Examiner can ask any question to draw. So you will make a graph like this, y-axis and x-axis. You label x-axis time and y-axis distance. Suppose this is in meter and this is in second. Since object is moving with uniform speed, it means it covers equal distance in equal interval of time, like I have explained you in uniform motion. So in 1 second he covers 50 meter. In second total distance he covers 100. In third second 150. In fourth second 200. If you join all these points, it will come a straight line. This type of graph is for uniform speed and uniform motion. Take any arbitrary values. Now, as you know, graph for non-uniform data is always curved. Similarly, if I ask you to draw distance time graph for non-uniform speed, it will also be a curved. So, again, for 1 second, total distance covered will be 10 or 15. So, I pointed here. In second, it is 70. In third, it is 150. In fourth, it is 200. So, if you join all these points, it will be a curved line. So, therefore, distance time graph for non-uniform speed or non-uniform motion is always a curved line. Then, if I ask you, draw distance time graph for an object at rest. So, it will be a straight line parallel to time axis. Suppose you are sitting in your room and your mother is also sitting with you but some distance apart. So here you take your mother as origin and measure your length from your mother. It comes 100 meter. You are at rest and your mother too. So for 4 seconds your distance will remain same from your mother. So that's why it will come a straight line parallel to time axis. 1 second, distance is 100 meter. Then after 2 seconds, distance still remains 100 meter. Third, 100. Fourth, 100. So if you join all these points, it will come a straight line. Like it is represented or drawn here. It is parallel to time axis. Now, if I ask you, draw velocity time graph instead of distance time graph, so what it will be? So now I will explain velocity time graph. First is when velocity time graph, when object is moving with constant velocity. See here, this is a graph of velocity time graph of an object moving with constant velocity. Means, like you can see in this graph, for after 2 seconds velocity of your car is 40. Then after 4 seconds it remains 40. Then 6, 40, 40, 40, 40. So it will also be a straight line parallel to time axis. Like I have discussed with you the third case of distance time graph when an object is at rest. Since distance is not changing with time, so it is parallel to time axis. Here velocity is constant, so it will be parallel to time axis. Now if I ask, draw distance time velocity time graph for uniform acceleration. Uniform acceleration means velocity of an object increasing by equal amount in equal interval of time. Whenever uniform comes, you have to draw a straight line like this. no matter what is given here, whether it is a distance or velocity, anything. Whenever you see a uniform word, draw like this. So it means velocity time graph for uniform acceleration. For 1 second, velocity is 20 meter per second. After 2 seconds, velocity is 40 meter per second. So it is increasing by equal amount in equal interval of time. 1 second it was 20, after 2 40, after 3 60, after 4 80. So if you join all these points, it will be a straight line. This is a case of uniform acceleration. Now I will explain you velocity time graph for non-uniform accelerated motion. Non-uniform accelerated motion means unequal distance in equal interval of time. Like you can see here in this graph, it is a curved graph. Like I have explained you in case of non-uniform motion and non-uniform speed, it is a curved line. So in case of non-uniform accelerated motion, it also will be a curved line. But if I ask you to draw velocity time graph for non-uniform retardation, retardation means your velocity is decreasing with time. Like you are moving with velocity 80 meter per second. Okay, and after 80 meter per second, after 1 hour or after 1 second, it becomes 60, then 50, then 40, then 30, then 20, then 10, then 0. So this kind of decrease is called retardation. Whenever your velocity of your vehicle increases, you call it acceleration. When your velocity decreases with time, you call it retardation. Like when you apply a brake to your bicycle does not stop instant. It takes time to stop. So in that kind of motion is called retardation. And it can be anywhere, in your car, in your bicycle, any vehicle takes time to stop, or this type of decreasement in velocity is called retardation. See here, for 0 second means your car is moving. You took your data when your car was moving. So for 0 it was 80, then 1 second it becomes 70, then 2 second it becomes 40, then 3 it becomes 10, and 4 it becomes 0. So it is decreasing. This type of decreasement in velocity is called retardation. And I have introduced non-uniform because it is decreasing non-uniformly. Like 1 second it became 70, in 2 seconds it should be 60, but not, it became 40, then in 3 seconds 10, 4th 0. So this type of non-uniform data is called non-uniform retardation. I have forgot to draw a graph for uniform retardation. So this is your homework. You have to send me your pictures for velocity time graph for uniform retardation. Like you just subtract it here, velocity time graph for uniform retardation. This is your homework. I will ask randomly next week, so be prepared with that. Now I will introduce the concept of slope. What is slope? Slope is just ratio of y-axis to the x-axis. Simple. See here. slope y2 minus y1 upon x2 minus x1. Okay, if I draw a graph or see this graph above, now I say to calculate slope of this graph. How you will calculate? First, choose 2 points. Let us consider this point A and this point B. Then draw lines on x-axis and y-axis from each point. So this is first one, this is on y-axis. For B, this is on x-axis and this is on y-axis. So slope is y2 minus y1 upon x2 minus x1. y2 is what? This is y2. Since it is on y-axis, and y2 is always value which is greater than other value. And this is y1. This is y2 and this is y1. And this case is x2 and this is x1. So this was a case like that. 150 is y2 meter, y1 is 100, x1 is 2 second and x2 is 3 second. If you subtract y2 minus y1, it comes 50, and x2 minus x1 will become 1. And slope, as I have told you, y2 minus y1 upon x2 minus x1. So this is a case of slope when the motion is uniform. So slope is calculation. And see here, y2 upon y1 is distance and x2 upon x1 is time. Slope y2 minus y1 upon x2 minus x1. In case of distance time graph, y2 minus y1 is distance and x2 minus x1 is time. As we know, distance upon time is velocity or speed. So that's why we say the slope of distance time graph gives velocity or speed. Like you can see in your notes, I have written on the top, slope of distance or displacement time graph gives speed or velocity. As you know, distance upon time is speed. So if you find slope of distance time graph, it will give you magnitude of speed, value of speed, whereas if you find slope of distance time graph, it will give velocity. As you know, velocity is ratio of total displacement upon total time taken. So I can ask you to find slope of velocity time graph. So what it will give? It will give acceleration. This is also your homework. You have to explain me concept of slope of velocity time graph to calculate acceleration, like I have explained you how to calculate slope of distance time graph, and it gives speed or velocity. So this is your homework, students. I hope you understood. If you find any difficulty, then you can call me. I will ask on next week randomly to any of you. So be prepared with. See here, slope. It is the change in y value between 2 points over the change in x value. That is, you can see in this graph, I have made a graph between distance and time. It is for uniform motion, so it will be a straight line. He took 2 points A and B. He drew a line parallel to x-axis and y-axis from each point. So from B, it is like that. On x-axis, it touch T2 point. On y-axis, point B touch S2, and on x-axis it touches T2. From point A, similarly from point A, value of x-axis is T1 and y-axis is S1. So if you subtract these two, S2 minus S1 upon T1 minus, it should be T2 minus T1. So class, correct it. It should be T2 minus T1. So do correct it. I will check it. It is the concept of slope. Just take the ratio of y-axis value upon x-axis value. Difference of y-axis value to the difference of two values of x-axis. Just this is the concept of slope. Why we use the concept of slope? Because you can see you just made a graph here and you calculate this value, you will get speed. So if I give you the data of distance and time and I ask you to draw a graph of that and now tell me speed of an object, you can automatically tell me speed of an object, because you know by slope of distance time graph for uniform motion, slope gives us speed. So this is the beauty of graphs. That's why we use graphical representation of motion to calculate speed, velocity, acceleration. And retardation, like I have explained you, what is retardation? Retardation is a body is said to be retarded if its velocity decreases with respect to time. This process is called retardation. For example, motion of bicycle after applying brakes. Both points I have explained you earlier. So this is a case of retardation. I hope you understood this point of retardation. This is important. In case of retardation, you will observe that value of A will be always negative, like we have done in numerical. I show you. I hope you corrected here. This value should be negative A. Here after calculation it comes minus 0.0185 meter per second square. This is a case of retardation. Whenever we apply brakes to any vehicle, our acceleration decreases and it comes negative. So, what is the difference between velocity and acceleration? First, write the definition of velocity. As you know, in every difference, first we write definition. So this is the definition which I have explained you earlier. Then formula, we know that velocity is displacement upon time and acceleration is change in velocity to the total time taken. SI unit of velocity is meter per second and SI unit of acceleration is meter per second square. Sorry class, this is a mistake, so correct it. Acceleration unit is meter per second square. And fourth point is V is 0 when body is at rest. V can only be 0 when body does not move, whereas A can be 0 if body is moving with constant speed. A can be 0 if a body is moving with constant speed. How? We know that A is equal to v minus u divided by t. So if a body is moving with velocity, constant velocity, suppose 50 meter per second. So v and u will be same at any time, that is 50 meter per second. So if you subtract v minus u, it will come 0. And if anything on numerator, that 0, the result is 0. So that's why in difference I write E is 0 when body moves with constant speed. So this is the concept of difference between velocity and acceleration. Now, equations of motion means equation to represent motion. These are the three equations of motion which we use in numericals and to calculate any derivation. First equation is v is equal to u plus at. This can be calculated here like that. We know that a is equal to v minus u by t. If you cross multiply it, it will come v minus u is equal to at. Take this u on right hand side and it will become this, v is equal to u plus at. Second is ut plus half at square, and third is v square is equal to u square plus 2as, where v is, we know, final velocity, u is initial velocity, and s is displacement or distance. Any case, a is acceleration and t is time taken. These equation has been derived by scientists. We will not discuss their derivation here, but we will derive these three equations by graphical method. So we will discuss first how to calculate this equation by graphical method. See here, equation for velocity time relation by graphical method means we will draw a graph. From that we will calculate this first equation. So suppose this is an assumption. Object is moving with uniform acceleration a. Its initial velocity is u and final velocity is v. Here I have drawn a graph. An object is moving with uniform velocity. So I will take a graph between velocity versus time. So uniform velocity means it will be a straight line, and this shows that the object is at rest. So I again repeat, this graph shows that object is moving with constant velocity v. See here, for graphs I have explained, if a body is moving with uniform velocity, it should be like this. It should pass from origin. Here it is not passing from origin. I draw line from point U. This gap shows that at this point velocity of object is u. After that it becomes v and it remains v. So therefore I draw straight line from point U. So object travels with velocity v after point U. So again we take the concept of slope. This is point B. I draw a parallel line to x-axis, which is time, and a line parallel to y-axis, which is velocity. And for v, I will again draw a line parallel to x-axis, which is time axis, and if I draw parallel to y-axis, it is point E. So I again repeat, I Class, I think I should teach this concept of graphical representation of method, calculation of equation, motion of equation in next class. It takes time to understand this topic, so I will teach you this topic next week. Thank you, class. If you find any difficulty, then call me, do call me. And remember, correct the correction which I have told you. Unit of acceleration is meter per second square. Do correct it. And acceleration, last numerical of last assignment was 0.0185 something. Add minus to that. Thank you, class. Student, I thought I should discuss questions of assignment which I have given today. So before saying bye, please have attention here. Question first. What is the nature of distance time graphs for uniform and non-uniform motion? Answer is the slope of distance time graph for an object in uniform motion is straight line. As I have told you, whenever you see uniform word, just write straight line in case of graphs. In non-uniform motion, it is not a straight line, or you can write curved line, anything. Second is, when can you say about the motion of an object whose distance time graph is straight line parallel to time axis? I have explained you that if you draw a distance time graph, this is distance and this is time, and graph comes parallel to time axis, it means object is at rest or stationary. Stationary means rest. You can write anything. Third question is, what can you say about the motion of an object if speed time graph is straight line parallel to time axis? Again, the object is moving with constant speed, which I have explained you earlier. Here the graph speed versus time. Speed, suppose I write v instead of full name, this is t. It is parallel to time axis. It means the object is moving with constant velocity. At every second, the speed is same. So that's why it is parallel to time axis. What is the quantity which is measured by area occupied by the velocity time graph? Yes, class, this is the question of last PDF which I have shared with you, and here I will explain. I forgot this concept to explain. See here, velocity, or wait, I open that PDF and I explain you in that PDF itself. See here, velocity time graph. I have written area under velocity time graph gives displacement covered by an object. How? Displacement we know, velocity we know. Velocity is equal to displacement upon time. Just cross multiply it. So what it becomes? Displacement is equal to velocity into time. V is equal to S upon T. Cross multiply, S is displacement. So S is equal to V into T. Here take these point A and B. How we calculate slope? We take 2 points on graph. We draw parallel lines from that. So we will draw parallel line on x-axis, or we draw perpendicular on x-axis. On y-axis we cannot draw because it's a straight line parallel to x-axis. So AC into CD. What is AC? This. And into CD. This. This is AC multiply CD. And what is AC? 40 kilometer. This is AC 40 kilometer. And how we will calculate CD? 12 minus CD is equal to 12 minus 6. As you can see in graph, CD is equal to T2 minus T1. Value of T2 is 12 and value of T1 is 6. 12 minus 6 is equal to 6. Multiply these quantities, it will come to 40 kilometer. Or you can see AC into CD is what? Length into breadth of rectangle, and length into breadth of rectangle is what? Area. So that's why area under velocity time graph gives displacement covered by an object. We introduce area here because area of rectangle in velocity time graph gives us displacement. AC into CD is what? Length into breadth of rectangle ABCD, as you can see here. So I think you understood why the answer of fourth question of last assignment which I have discussing with you is displacement. I show you that question. Wait. What is quantity is measured by the area occupied below the velocity time graph. So it will be displacement. Area of rectangle in velocity time graph gives us value of displacement. So thank you class. I hope you like my teaching way. Thank you. Bye. Stay safe, stay healthy, stay right thing. Bye class.